While I am at no significant milestone in my project since the last update, about a week ago, I thought I would at least share a cursory update of what I've been working on this past week. Really, my focus has been on the schematic side of things. I'm not worried about the PCB at all, other than I'm laying out some of the components to get kind of an idea of the physical footprint that these components are going to take and what kind of board it's going to take to fit all of this. All the routing and power distribution and how many layers of the board and all that stuff I'll come to later. So if you see anything on that side of it, I'm not worried about that yet. Now on the schematic side of things, maybe what I'll do is kind of switch over to just this note tool that I've been using to just kind of remind myself what I've been working on and maybe some of the things I have to do. I'm kind of keeping a backlog of all the work I have, and like I mentioned in the last video, I think that backlog will grow as fast as I can clean things off of it. But maybe since the last video, some of the things that I've come in and done is I've added support for analog power and this PLL power. And so what I did over here on my power page, I did just come in here and add in, I believe, what are the necessary components to really add a pair of ferrites. That's what these would be here, along with a pair of capacitors to get me my 1.8 analog power and then also an analog ground. Now I will comment, I have just kind of picked a ferrite that I've used on another project, but I've listed that as a to-do. I need to come back and actually verify what specific ferrites I should be using. But in general, this is just a placeholder. So this is a 0805 ferrite. And before I get to actually routing the board, I'll go in and verify what do I need to use for ferrite beads there. But I've got a couple of placeholders for that. Same for this PLL, and I don't yet know where that's going to come into play yet, but I did lay this out based on what I was learning. I do know I need to come back and maybe revisit all of these capacitors, but this is how it sits right now. Things that I'm going to revisit is just double check the values and also the physical sizes and choose kind of my final, what am I going to use there. All of that is coming along just fine. If I go back over here, outside of that, I did add a USB connector. So I've broken my USB into two sheets. And so then I did come in here and add a USB A connector. And this will eventually connect up to this USB 3320. And that's kind of this ULPI PHY that will let me do this, either being a USB host or a device, I suppose, if I want to do that. Now maybe another comment in my list of things that I've been working on is this USB connection of this FT2232, and that's more for the programming and then serial, like USB serial connectivity to the sock. And with that, you can see there's quite a bit here. And again, this is a first pass through this, but I have the FT2232, I have a USB-C connector, and I'm pulling out the data lines from that. I did have a question about, it seems like there's a debate out there on the shield or the shell of this. I've just right now got it going through this MH2029, another one of these ferrite beads, down to ground. I'll have to see if that makes sense or if there's a different thing that I need to do there. And I did mark that as a question. I think on a lot of the schematics, I see that this comes down to an earth ground. And I'm not sure, no, not an earth ground, a chassis ground. But I'm not sure what I would need to do for that. So for now, this is what I've got, is I've just put this ferrite in between. If any of you have any good resources for that, feel free to drop me a note. Otherwise, that's something I will research later as I get time. I guess I have come in here. I have put in a fuse right up here, and I set it with a trip of 1 amp and a hold of 500 milliamp. And I believe for typical USB 2.0, 500 milliamp would be pretty normal as far as what it could supply. And as I was reading up on fuses, then the question is, should I have a hold at 300 and trip at 500, or have it hold at what I really want to be able to supply? And then this was the the closest trip I could find was a 1 amp. So that, I think, is what I'm going with for now. And I'll continue to research that, but that's a 1206 little fuse here that trips pretty quickly, and it will trip when it hits 1 amp. I have that USB-C connector then coming into this FT2232. It looks like that does require some type of flash memory, so I have in 2 kilobit of flash memory to connect to that, and I need to learn later what to actually do with that. I'm going to assume that there's some program that needs to be placed on it, but I'm not sure yet. Looks like there is a 12 megahertz oscillator that's needed for it, so I also have that here in the schematic. So that got the USB-A connector, and then my start of this, which will need more work, but it's at least a start to get going on it. Okay, so I've got that. I've got the analog, or the USB-A, and I've got this. The DDR symbol, I know I had feedback on that symbol that I was using, and I'll just show you what I did there real quick. So I did go into the DDR and change that. So first of all, here's the part of the sock that is going to connect to the DDR, and I have a pair of the DDRs, but I did rearrange. Obviously, I just modified the symbol that was there. The one I was using was just from the system library for Easy EDA Pro out of their system library, but basically I just took that and modified it and rearranged it in a way that I thought made sense, or at least for now I think makes sense. Maybe later I'll do some further rearranging of that. And then I did connect in whether it's the data lines or the address lines. So the address lines I think should be the same going to both chips, and then the data lines will get split, low word, high word type of thing. And then I did connect up power and ground, and that's all I've done on this so far. So all the other signals, I need to go through some learning content on that. And I think in the video series that I'm going through from Phil, he does get to a DDR section coming up that I'll take a look at, and then try to get this connected up after I go through that. But this is what I've connected up so far, along with some bypass capacitors for those 2 different ICs. So that is a little bit cleaner symbol, and then that was a start of my DDR connection and DDR caps. And then again, I've added a fuse both for the USB and also for the DC barrel. So when I go over to my power, I can also bring in power through a barrel connector here, and then I run that through a fuse. And what I picked for that was a 3.5 amp hold and a trip of a 7, which I can go something smaller capacity wise, but this one seemed reasonable that if I can, keep a steady 3.5 amp, that should be way more than what I'll need for this board. So maybe I'll pick a smaller one later when I actually get closer to that. I did add a pair. I've been using these 68-pin expansion connectors, so I added a page for that and just have 2 placeholders for those connectors just sitting here, and I'll come back to those later. I did add power rail indicators just so that when I get to my power, let's see, back on the regulator page, I added these up here so that I can, when I have my 5 volt coming in, I can light up an LED. Once I eventually get my 3 volt running, I can light up an LED. And I'll play with these resistors and try to get them to be comparable brightness with whatever LEDs I put in there. But then for the 1 volt, the 135, and the 1.8, I'm just using a transistor there, which I think is sufficient to get these LEDs driven. I did that on a different PCB, and that seemed to work just fine. So that would be those power rail indicators. On the flash that I had previously mentioned I was using, I've got this on this program sheet. I did change that out, and the flash I was using was an 8-pin SOIC. I flipped that to a QFN package, and the reason being is on the 8-pin SOIC, the largest I think I could find, and I didn't look too hard, but it seemed like as I looked through DigiKey as an example, I could only find 128 megabit in that same footprint. and then the larger ones went to more pins, or you had to go to a QFN. But if I go with the QFN package, I can go anywhere from a 128 to a 256 to a 512 with an identical physical footprint, I believe. So I could start out with a less expensive 128, and if I later want more memory, I could put a 512. And so I did swap that out, and then you also see that I mentioned I connected the flash, so I do have the connections. And really just going through Phil's video and how he's working through that. I'm kind of just following along, I guess, as I go through that. So what you see here is really my takeaway from the video that I'm taking, or the class that I'm taking there. So that takes care of these. As far as a JTAG connection, did also come in here and get that hooked up. Digilent has this JTAG HS2, and that's a 6-pin. So I just made a real quick little device for that, so that I can supply the 4 pins and then VDD and ground, or my 3.3 volt and ground, and got that connected up to the SOC. So I've got those signals for TDI, TDO, TCK, and TMS. And then also done init program B through a switch. Did put in some of these for some level of ESD protection. And that really got me through, this here. And I do have a done indicator also that I added in here. So similar to other things I've done there. So I think that should work. I did add an SD card, just the physical slot for now, and I don't know if this is the actual one I'll use in the end, but I did put it there just as a placeholder so that I could see how much space it takes up on the PCB, and it is a lot of space, but I put that there just so I don't forget. And I do understand, my understanding at least for now, is that I do need some voltage levelers as I get into that SD card, so that's something I'll have to come back and work on at some point. And then I did start to get into the processing system, clock, power on reset, reset boot mode. And so over here I've got processor, and this is as much as I filled in so far on the processor side of things. And so then I've got basically a clock for that, a 33 megahertz clock, or 33.333. And then I do have power on reset, and this was following the pattern that Phil's video had used to get that signal, so that it really doesn't turn on until after I get all the way through all my power and get to the 3.3. And as a reminder on the power, that is sequence, so it starts up, 5 volt will be turned on, and then I'll output my 1.0, then that'll turn on the 1.8, turn on the 1.35, turn on the 3.3. And once that 3.3 is on and the power good is there, then I can continue. And actually this power good 3.3, as I noticed that's not where I wanted that. I actually wanted this down here. So I'm going to, for now, just put this in. I'll have to clean this up later. Okay, so that's where I meant to have this little power good flag. But when this 3.3 turns on and its power good is up and running, then I should have this power good flag, so that when I get back to the processor, I know that my power is good at that point, and then I can get this signal flipped for the taking it out of reset, I believe. So more to do on that, I'm sure. Then I've got a real quick reset button. I don't like the buttons I've chosen for now. They're the traditional style button. I might try to find something a bit smaller. I don't need the physical size of these that I have in there for now. In Phil's video, he's also running an LED off of a pin on the processing system. And so for now, I've brought that in here. And then I've also connected up these signals, DQ0, 1, and 2, that are used to select the boot mode. And so then a little 3 switch, dip switch, to help manage that. And that gets me through, all of these here. And so then, yeah, if I real quick just save, let's see, everything's saved here. Let me update my PCB real quick. And for now on the PCB side of things, I'm just, again, trying to find general spots to lay things out. I know when I get to the routing, things are going to move. I know I'm going to have lots of challenges on the routing side of this as I get into it, but this is what I have so far. And maybe what I'll do is just go to the 3D view and maybe just talk through some of the parts that I've got here so far. So again, I've got the Zynq-7000 sitting here. On the back side, I've got all kinds of capacitors that need to be placed yet. And I did put a note here. These aren't actual placement. And clearly this is definitely not actual placement for this other stuff, but a lot of capacitors that I've got to work through placing in time. Then I've got the DDR3 sitting here. Here's that header for programming, basically my JTAG header. Here's the SD card slot. Here are those pair of those expansion connectors that may or may not stay on here. We'll see at the end what things look like. I could imagine maybe one off of the processing system and one off of the FPGA side of things might come off of this. And I do have some other type of surface mount expansion type connectors that are a high density that I might also potentially use. I'll just have to see at the end of the day what I really have left for IOs that I think I might use off of this board. Again, I've got my Ethernet over here, and then I've got this Ethernet transceiver sitting right up here. And you're going to see around this, I have these little TPSs to do my buck regulation and the inductors that go with that. Here's a USB-A connector. In the last video, I didn't have that connector on there. I just had this one down here, but I got this added on here along with the ULPI PHY that'll connect to that. Down here is my USB-C connector. And like I mentioned, I think my expectation is I could use that both to supply power and then also to do programming and also as a USB serial interface. And this is that oscillator that goes with that. Again, I don't know where that'll actually get placed, but that's where I dropped it for now. And here's this 33.33 megahertz for the processing system, which I just temporarily dropped right there. There's my barrel connector. I have a fuse for this USB-C, a fuse for the barrel connector. I can choose the power source, either the USB-C or the barrel connector, by moving the jumpers up or down on this. Here's my boot mode, dip switch selection, my reset switch, my program switch. This is this FT2232 UART, and this should say FIFO. So let me go fix that. And then I still just have these two HDMI connectors floating up here. There was a recommendation to maybe protect that or protect the system from, I guess, things coming in from that power, whatever it might be, or static. So I did add in my to-do, or in my backlog, I guess, HDMI along with maybe a TPD 12S016 was recommended. So I'll read up on that and see if I can get that put into that circuit when I get to that point. That's a little ways down the road for me, but it's in my backlog. So I think that's about it. I did add some 0201s resistor capacitors up here. I might just try to do some test soldering with those. I've done 0402s and those have been fine. I have not yet tried to do anything with 0201s. And I may order just a kind of a blank version of this PCB at some point that at least has all of the voltage regulation, working on it, populated on it, and maybe out to some test headers or something that I can put a load on them and just verify sequencing and everything's working the way I want to on that part of it. And maybe as part of that, I'll throw on some really small components just for some testing of my soldering to see if I even want to do anything with the 0201s. Because I think some of these capacitors that I have back here, I'm going to change to be smaller so that I can place them underneath the FPGA. Looking through how Phil's approaching that, it seems like he's been able to do that pretty well. So I might try to follow suit on that. but I don't know if I can really manually manage the 0201s yet, so I'll have to do some practicing. But I might order up one of these as a 4-layer board, and I think that would just give me enough to have an inner plane ground, and then have, you know, the rest of this power and power sequencing, just test that and test some of this small soldering. Obviously, the rest of this I would not populate, but, you know, for $7 and a couple of dollars shipping, so for $10 to test out my power and this over here, that might be a worthy test. But I might wait a little bit before I get to that. Yeah. Let's see if there's anything else on here that I missed. I think that should be everything that I have so far. You know, I've got different indicators, which I don't necessarily have them all labeled yet, so I'll have to do that. You know, on the back side of this, again, I've got a lot of capacitors, so that DDR seems to have a lot of capacitors, and those are all just sitting here for now. I guess I do have this. Here's my QSPI flash, and then there's a little flash that goes along with the FT2232, a little 2K kilobit flash. And I don't yet know what needs to be done with that. I just know that it was in the reference design I was pulling from. And assumption, again, is that that's going to have to be programmed to have this UART work the way I want it to work. But again, I can be wrong on that. So that's what I've got on that. I guess if I look at upcoming things, I know I need to work through this USB 3320. That would be this one right up here that I need to get hooked up in the schematic. All the HDMI, I'll have to figure out how that gets hooked up. The DDR, finish getting that connected. Same with the Ethernet, and then look into the SD card connection. And as far as my to-dos right now, I've got a whole bunch of schematic work just to name all the nets. So for a lot of this, you know, if I go in, well, let's just say I go over to my, I'll pick my USB here. You know, I don't have all the net names labeled. So like here, these are all labeled. I've got something there, and like something here. Initially, I didn't have these two, but then when I get to actually laying out the PCB, that's not real helpful. Whereas if I put these net names on here, once I get to the PCB side of things, then I can see those. So like in this case, I put these LEDs up here, and that then comes across right here, so I can see where my receive and my transmit pins are on this chip, instead of seeing some pointless name like you see with these connections here. So I got a whole lot of that to do, and I will slowly work my way through and do that. Oh, I have a lot of capacitors that I'll change around, I think, as I get going, and I've got some notes to do that. Thinking about a 10-layer stack up, and I did 10-layer, or is it even possible to go 8-layer? I think that 8-layer would be too much of a stretch for me, but I should be able to get a 10-layer done. Phil's given a lot of examples with his reference design, and this is at Brett. And that's a 10-layer, so I would hope that I would be able to get a 10-layer working. And I think he even commented in his video that he probably could have done 8-layer if he would have wanted to. I do know the price difference between an 8 and a 10. There is a pretty big price difference between the two, so I'll probably start out with a 10, and if I get through that, maybe then I could look and see how far I would be from getting to an 8-layer. But this is the potential stack up that at least this one here on the left is what Phil laid out in his video as an example. And maybe that's something I could take a run at. I've been reading up a whole bunch and watching the videos on the controlled impedance. So that is quite interesting, a lot there. And again, I've been going through this course here. This is Advanced Digital Design, but then I took some time and went through some of Rick Hartley's stuff. Awesome stuff. So a lot more there that I could be going through. So between Phil's content and Rick's content and just other FedEvil videos, there's just so much there. I could probably spend months just watching those videos. Just scan through if there's anything else here. You know, heatsink fan mounting, maybe that's something I do need, and I have kind of a placeholder on my PCB for that. I do want to go back and kind of just validate all my power if anything, I should be far above what's needed, but maybe I can go with some less expensive components if I back it down a little bit. And like I said, I probably want to order a test PCB that's just simply a 4-layer just to do some testing of my power setup. I am reading through these 2 books right now, so these are really good books. But each of these books probably could take me 2 months, 3 months, 4 months just to go through. These are some pretty meaty books, so a lot of content there, and definitely not stuff that I understand going through it the very first time. So these will be good reference books, I guess, as I go forward. So I'll see what I learn from those. And I know I have a lot to learn about DDR, this whole controlled impedance. This is really the first PCB that I've really ever paid attention to impedance, and try to work my way through some of the calculations and things like that, and try to do better at that. And then USB and Ethernet, I've not worked with those really before either. So a lot of stuff right there in those 4 things that I need to work on. But I think that's it for this video. So I just kind of wanted to at least show the progress I'm making, walking through. I've got a couple of banks here that I've not done anything with yet at all. They're just sitting on this holding page. I think my regulators are probably sitting in a decent spot. This power is generally on the right track, but we'll need some more work. I've got a whole bunch to do. Maybe the programming is getting pretty close, but the memory here, the DDR3L, I got a lot there. If I get into this USB, this might be pretty close. This USB here for the the USB host type of stuff is not started yet. Really, I just have some power connections, so really not much there yet. Nothing on Ethernet other than just some initial power connectivity, just starting the processor connectivity, processing system, and really that is just so that I can do basically the connectivity to the flash. HDMI, nothing there yet. Expansion, nothing there yet. These banks are pretty much empty at this point, and same with the SD card. So that is my current spot in this project. So a lot more work to come. This is not really meant to show the next milestone, like I said at the intro, but just kind of a in-between state of where I'm at. I'll keep chunking away at it. And then I'll get back to the actual PCB design as the schematic starts to settle down, which I'm a little ways from that yet. But once I get to the point where I think I have all the components in the schematic side of it, then I've got to come back here and actually see where should things ideally be placed, move things around, get things placed properly, get my 10-layer setup configured, and then see if I can start routing, some of the more complicated things, like I think USB is one of those, and then this DDR3L memory will be another one where routing I think is going to be really important and will stretch me a bit.